So these say to graph the function. It says to compare the graph with the graph of f of x is equal to x. So basically, like, how is it different? I'm not worried about that part. So let me see. Put some lines up here. All right, so number 24. H of x is equal to 6 plus x. So we could do this the way that we were doing the problems in, like, what, 2 or 3 sections ago, where we were treating this like y equals, and then we could just swap these two things. So it would be x plus 6, and we could graph with the y-intercept and slope like normal. But the way that they officially want you to do in this section is to pick some points like you did in these earlier problems. Where is it? Like these, to pick a couple points and then plot those points on the graph. So I'm going to show you that way, and then if we want to do a review of the graphing with slope and stuff, but y'all seem to be pretty good with that. So again, I don't mind whichever method you want to use, but we can kind of pick whatever numbers we want to use here, just to not make the graph so big. Well, I'll just use -1, 0, and 1 because that's kind of what we used way back when we started doing these types of problems. So it'll be h of -1 is equal to 6 plus -1. So 6 minus 1 is 5. So this is the x point, this is the y value that comes out. So the point that we'd be plotting is -1, 5. So that's going to be 1 point. I'm going to do another one, so I'm going to do h of 0. So 6 plus 0 is just 6. So then this point is 0, 6. And then h of 1 is 6 plus 1, which would be 7. So this point is 1, 7. And then we would just set it up and we would plot those points. Now, my guess is you probably like the slope and y-intercept method better because it's not so much work. But anyways. All right, so at -1, I have a point at 5, so -1, 1, 2, 3, 4, 5. At 0, 6, 1, 2, 3, 4, 5, 6. And at 1, it's 7, so 1, 2, 3, 4, 5, 6, 7. Do y'all like this method, or do you just like slope and y-intercept better? This method? Okay, that's fine. All right, let's see. 26. M of x is equal to x minus 6. So what points do you want to use to plug in this time? I'll let y'all decide. And it doesn't have to be the ones I use. You can make up whatever point you want to use. As long as we do 3 of them, I don't care what they are. -2. So this one we'll do this one and then we'll go through and do another, we'll pick another one. So -2, n for x, minus 6. -2 minus 6 is? -8, yeah. So same sign, we add them and keep the sign. So it's -8. So this point would be -2, -8. All right, so then what's the next point that you want to test?
4.
What number?
4.
4? So we plug in 4. So we have 4 minus 6, which is what?
2.
-2. So this is the point 4, -2. And one more. Three? All right, so m of 3. So 3 minus 6 is what?
-3.
-3. So this point is 3, -3. So then I'm going to set this up. So then we plot these points. So at -2, I go down 8. So -2, and then down 1, 2, 3, 4, 5, 6, 7, 8. And then 4, -2. So 1, 2, 3, 4. Then 1, 2. And 3, -3. So 1, 2, 3. 1, 2, 3. And then my very curvy line. And we can connect it. So you can pick any number that you want to plug in. It doesn't have to be the same numbers every time. You can be like, I'm going to roll a dice and I'm going to pick 6. I'm going to flip a coin and I'm going to pick 2. Like, you can, you know what I mean? Like, you can choose whatever numbers you want to plug in. Let's do 30. This one is W of X is equal to 5X. So what number do you want to plug in first?
2.
What do you say?
2.
2? So W of 2 is equal to 5 times 2, which is
10.
10. So this point is going to be 210. What else do we want to plug in?
1.
1. So W of 1 is equal to 5 times 1, which is
5.
5. So this is the point 1, 5. All right, and last point.
4.
4. So this is going to be 5 times 4, which is
20.
20. So 420 is going to be this point. So I'm going to count by 5s just to make it not so big on the y-axis at least. So again, just remember, if you are going to change the increments, note what you're changing it to. So I have the point 210. So on the x-axis, I'm going to go still just normal. I'm going to count them as 1s. And then up to 10. So 5, 10. So I have a point here. 1, I'm at 5. So it's here. And then 4, 2, 3, 4. I'm at 20. So 5, 10, 15, 20. And then connect. Any questions about that? All right, let's do one more. Y'all seem like you're getting this pretty good. Number 34. M of X is equal to -7/2 times X. So with this one, okay, to make life easier when you're picking points, I would choose even numbers. Do you have any idea why I would say that?
Because of the 2.
Yeah, because of the 2, because it's going to cancel, so I won't have to deal with fractions. If I pick an odd number, I'm going to have to deal with fractions, which not that's a bad thing, but I'm guessing if you're like most of my other students, you don't love fractions.
No.
So by picking an even number, okay, any even number or even 0, we won't have to worry about fractions, okay? So I don't care if you choose an odd number. If you're like, oh, I just really like the number 3, so I want to use 3. That's fine, just not my recommendation.
Okay.
So what number do you want to use first?
0.
0, okay. So negative 7 over 2 times 0 would be 0. So I have a point at 0, 0. What's another point? 2. So I have negative 7 over 2 times 2, which would be what? Or what happens to these
Negative.
2's?
They cancel out.
They cancel, so that leaves you with negative 7. So that 2, it's negative 7. And then I need one more. What is happening?
Negative 2.
Negative 2? That's fine. That's fine. That's a good one to pick, so it lets us see something else. So negative 7 over 2 times... Hi. Sure.
I'm just going to give you your stuff.
Okay.
But they do need to sing a song to you, so I don't know if you want to try to run over there and have them sing to you while they're all in modulars.
I guess I can. I'm almost done, so... All right, what happens with these 2's here?
They cancel out.
Okay, but what's different about this one compared to the last one?
It's negative.
So it's negative times negative, which is positive 7. So negative 2, 7. So then, oops. Oh goodness, this one I need a bigger graph.
I did that, and I was like, what the heck? Could you do that?
All right, so at 0, 0, I have a point. At 2, down 7. 1, 2, 3, 4, 5, 6. Oh no, 7. I think that's 7. And at negative 2, I'm up 7. 1, 2, 3, 4, 5, 6, 7. So this graph was going down this time. Oh boy, that's not a straight line. Okay, it fixed it. All right, any questions about that?
Oh god.
Okay.
It was creeping me out, though.
All right.
Because I kept on moving during us talking. I was like,
So 23. Thank you.
Yep. Like, do they have one song?
Do they already have the slip, or do I need to take
They
it over
have the
there?
slip. They're over there singing. They'll be over there singing for a while.
Okay, so I should
So
just
if
go over there in a
they're
minute.
finished, you can kind of pop in and say, I heard you had a
Are you
song
free
for
this class,
I am.
technically?
I'm kind of
Okay.
running around
Well,
putting
if I'm
out
running
fires.
over there, like.
Yes.
Okay.
I'm going to run over to second grade first to give them a couple extra balloons, but then I'll be back.
Okay. And wait, not 27. Hold on. Pause. I got distracted. 31 and 33. Now with 33, it's very similar to 34 that we just did, but it has a 3 in the denominator. So when you're choosing what to multiply by, because it's a multiplication problem just like that one, choose increments of 3. So something like 0, 3, 6, 9, so on and so forth. Okay, because that'll help because it's a fraction again.